So we're going to do another example that really highlights the power of working with this principal axis representation. So we have an object here that we're spinning about this AB axis with angular velocity theta dot. And this AB axis is perpendicular to the 3-axis, so that if we were just to look from the side of this object, this is what we would see. But when we look from the top view of the object, and I orient it so that now this 3-axis is going to be coming out of the board, I'm spinning about this axis, and this is the orientation of the object that I would see from the top. So from the side, it would be kind of tipped toward me. So from the top, I can really see that orientation. And there's an angle phi here between this AB axis that I'm rotating about and the principal axes 1 and 2, which are attached to the body. So we want to express omega in our basis vectors E1, E2, E3. And if we can do that, then we end up with the simple expressions that we derived before. So I have my 3 components that I need to work out for the omega vector. So our omega vector is along this axis. So I'm just working out components in this direction. And I have neglected to include on this figure that I'm also rotating about the 3-axis with a component phi dot. So this looks like a fairly complicated rotation, but I'm now going to express these components in terms of 1, 2, and 3. And so omega 1, I just do the simple projections onto the 1-axis, and that gets me a theta dot cos phi. Omega 2 ends up being a minus theta dot sine phi. And omega 3, this is just my phi dot. So if I want the kinetic energy, this is 1/2 I omega squared. And I can just instantly write down what the kinetic energy is of this body. So it's 1/2 I1 and I1 squared, that's a theta dot squared cos squared phi. And then I have an I2 theta dot squared sine squared phi, and then an I3 phi dot squared. And I'm done. So this demonstrates the real power of being able to use these principal axes. If I can express things in terms of the principal axes of moments and decompose my angular velocity, I can instantly write down quantities like the kinetic energy.